Welcome to challenge 3. Let's take a look at the technical drawing. It looks pretty straightforward, but there is one part that looks quite challenging, and that is the slanted cut we have that goes through the side that faces us. We'll be using some things we learnt in the previous 2 challenges to help us create that slanted cut. So let's head into SolveSpace. And it, again, doesn't have to be perfect because we're going to constrain these in a moment. I'm going to make these lines horizontal and vertical now. So this one has to be horizontal. Now, as a reminder, you can see this line looks horizontal, but it isn't. You need to click on the horizontal or vertical until you get the letter next to the line, and that is now definitely horizontal. Now we've got 8 degrees of freedom, and that's because we need to tell SolveSpace what the length of these lines are. This line is 88 millimeters, and this line is 18 millimeters. And you can see that we've got 6 degrees of freedom. So these lines need to be sorted out now. Well, we know that these have to be equal in length. So we select the lines and then select Constrain Equal Length button. So now they're exactly the same length. And this line here is 38 millimeters. You subtract 18 from 56 to get that. And you can see these 2 points are not horizontal, so I need to say that these 2 lines need to be the same length. And that is 12. And the only thing left we've got here now is 2 degrees of freedom because I can move the whole thing around. I need to anchor it. I'm going to select this point and that point and click Constrain Point on Point. And now we can extrude it by 50 millimeters. Okay, so the next thing I need to work on is this rectangular shape that's been extruded at the top here. So I need to create a new work plane. And select this button here. And now we're going to be working at the top of this part of the object. So whatever we put on here now will be flush with this surface. I need a rectangle. And let's constrain that. So this point and that line have to be overlaid over each other. So I'm going to constrain the point onto the line. And same thing on this side. Now that's constrained the length of the rectangle. Let's specify the width. And that needs to be 12 again. And we've got 1 degree of freedom left. And that's because I can slide this. So I need to specify the distance from this point to this line. 10 millimeters. Now we've got 0 degrees of freedom, so we can extrude this. And you can see it goes outside, but I want to say it's a union. I don't want to take the difference. It is a union this time, but I want this point to be flush with this surface. So I've selected that point and the surface, and now we need to click on this constrain point onto the surface. And now we've got a unified structure. And so far that looks good. If we look at the diagram closely, we see that we already have point C given to us, but we need to place A and B in the model. And A and B are in the same plane at the top of the model. I'm selecting these 2 lines and the point and clicking on New Group in New Work Plane. And I'm going to put B in first, and B is directly above this point down here. And if I rotate that, you can see now we've got B here. Clicking this button takes us back to our work plane. Placing A is a little bit more challenging, and that's because it's somewhere along the line here, and we need to calculate the position of that point using the angle that we have in our technical drawing. This is the side view of the model, so if I turn this to help you see that, this is just a sketch, it's not a very good one. The 45-degree angle goes from this point up this way, but it's between these 2 points, if that makes any sense. If you're not sure what I'm talking about, just have another look at the diagram at the bottom here. Since we know the angle and we know the height of the point, so we can work out what distance A is. So we can go back to our work plane, and now we know where to place A. Get a point, I'll place A somewhere on this line. Now what to do is click on these 2 points and specify the distance between them, which is 56 millimeters. And there we have it. We have A, B, and C was already given to us. I need to create a triangle that I can extrude to create the cut. But before I can do that, I need to create a work plane for that triangle. I'm going to click on the line sketch tool, click on A, but you see that it won't go to B. And the way to fix that is to click on this button down here. That allows you now to draw in 3D. So I'll click on that on A again, drag it to B, from B to C, and then from C back up to A. That's now a contour, but we can't extrude it. If I do try and extrude that, I'll get an error message saying that I need to have an active work plane first. Now there is a way of doing that. I can click on these lines, hit the G button, and when I select 2 of those lines and click here, that's now my new work plane. I now can create a triangle in this new work plane. It's just one of the ways that SolveSpace does things. Now I can extrude that model and take the difference and drag that difference cut through the model up this way. And we've got 1 degree of freedom left because I need to specify the depth of that cut. So I'll select the axis and I'll just say it's 20. That's just a number off the top of my head. Go to the isometric view, back in properties panel, hide everything, and then we have it. That was fun. Let's head into challenge 4.